Yes, we are ready. We can go live,
Okay,
Dr.
very good.
Parks.
Good morning, you all, and welcome to our presentation this morning. We have the pleasure of having among us today Mr. Brian Semino, who's a candidate for the farm director position. We've gone through first phase of Zoom interviews, and now he's in the second phase of going through the campus interviews. So we've asked him to give us a few words, brief presentation, a few minutes, to talk about his vision and what he sees as a role of a farm director, and maybe some suggestions as to how he sees. He's been on our farm already, so he's had the farm too. So he's seen what we're having, and make some comments about what he sees and his vision for the future in his role as farm director. But a little bit about him. He's currently a senior research associate in the Department of Soil and Crop Science at Texas A&M University. I found out this morning. I don't know how he got to A&M and bypassed LSU, because I found out this morning he's from Louisiana. We have Mr. Rapist Brew back there. So Mr. Brew is from Louisiana, and I spent 5 years of my life in Baton Rouge, Louisiana, so I'm familiar with where he's from. But he came over to Texas A&M and did his bachelor's degree in forestry, Texas A&M, and a master's. So it's something about those Aggies. I don't know what it is. He likes Aggies, but we like them too. So we're going to welcome him here. I'm not going to get into his all the details. He can tell you more about himself. But it seems like he's been working in this capacity since about 2008. So he has some years of experience, varied experiences in plant maintenance, harvest, and greenhouse activities, winter wheat cultivars, and things like that, and so forth and so on. So I'm not going to try to read everything that's on the resume, but we'll allow him to do that. So we present Brian Semino.
Okay, so like Dr. Park was saying, I want to give I guess just a brief introduction to my background and experience. I did want to talk a little bit about the projects I've been involved with, and also I wanted to share my vision, some ideas that I might have for our business. There we go. So in 1999 is when I started my Bachelor of Science forestry. I had an emphasis in urban forestry. That's mostly dealing with urban trees and horticulture plants and things like that. I finished my bachelor's in 2004, and when I completed, I went ahead and took a job in Dallas. I worked there for about 3 years, and I was mostly I worked a lot in downtown Dallas, which is why I only lasted 3 years. Traffic was horrendous and things like that. But I got to work with a lot of clients and IPM, talking about trees, give recommendations and things like that. So decided I wanted to move back to College Station. Wasn't really thinking about going back to school. Just wanted to get back to College Station. My wife was there and everything. But I did take a job as as a full-time research assistant. And I started working in the small range breeding program under Dr. Purity, research professor in small range breeding, and other research scientists. And we did just basically the field trials and greenhouse trials. So in 2010, I was promoted to research associate and took a leading role in hoop and spring wheat breeding programs. We usually have hard red winter wheat, we have spring wheat, hoop, and soft wheat breeding. And my PI was getting kind of overwhelmed, so I kind of took those two off of his hands. And in addition to my work, I was given the opportunity to pursue my master's. So at the same time, I'm working on my master's in plant breeding. And I completed that in 2014. So upon completion, I was promoted to senior research associate, and my responsibility through, and included management of all undergraduate and graduate students, equipment, budgets, purchasing, increased collaboration with other scientists from other institutions. Um, so in 2017, in addition to my full-time role as a senior research associate, I decided to continue my education with my PhD in agronomy. It should be done in December. Should have been done already, but that's a whole different story. Um, my focus was on forage biomass analysis using UAV technology, and I'll get into a little bit of that project later. So my tenure there at A&M, I was able to work with a lot of undergraduate and graduate students. Range between that, I was able to assist mentoring 25 undergraduate and 22 graduate students that came to the program from all over the world. Um, so in collaboration with the program leader, I provided assistance to graduate students, experimental designs, safety, equipment training. I provide a lot of assistance with data analysis needed. Many have gone on leaders to different universities and international centers. Very good experience working with students. In addition to my work there, I was able to take part in some international work. We were working with the Borlaug Institute, AgriLife Research, and also a private oil and gas company that has ties to both Houston and the Republic of Georgia, right below Russia. So I was part of this wheat improvement initiative. We had some overarching goals. We wanted to improve wheat quality and yields in the Kahieti region and give back to the local community. My role in the initiative would be to oversee the field preparation, planting operations, field maintenance, harvest, and determine the most effective method of overcoming equipment obstacles. Now, they had plenty of equipment. It was all very large scale equipment. So typically when we do, small plot work, we're talking about a 5-foot, 10-foot plot of wheat, and that was not possible here. So we ended up doing about a 50 to 100-foot plot, several different varieties. So it took up quite a lot of space, but I think we had good results in the end, and it was a really interesting experience working with those guys. So I want to talk a little bit about my PhD project because it has to do with forage. And I think forage is important. And, kind of my my project was looking at the full season annual forage biomass analysis by using UAV and ground-based technologies. Now, I based my project off of our annual forage trial, which we conduct, obviously every year. It's a multi-species. Wheat, rye, triticale, barley, oats. Got a few blends in there. And typically, this trial, it's pretty labor intensive. Which kind of limits us on how many entries we're allowed to do. There, you can see this is a forage harvester. We cut each plot and weigh it, things like that. So really limits the amount you can do, doing it this way. So I wanted to see there's a different method. Estimating how much forage potential are in different varieties and species. So I set out and I did a 2-part study. Study 1, I wanted to look at replacing that mechanical harvest. We don't have to take the whole plot and just see about doing different ways to estimate forage yields. So I looked at 3 different methods. I want to do a visual rating, so that's where I would go out, visually look at the plots and look at leafiness, height, overall vigor, and give it kind of a score of 1 to 10. The second part I wanted to look at is plant height, see how, if we can get some estimations based on plant height. So I did 3 height measurements throughout the plot, kind of got an average. And the third one was just doing a subsample. So as opposed to harvesting the entire plot, we just want to go sub 1 meter, linear row. Get the weights on that and see if that would correlate well with forage. Sorry. You're not able to hear me? Oh,
I'm able to hear, but it is far.
oh okay. Yeah. No, it's okay. Oh, okay. Free to move. Okay. So yeah, we wanted to look at just doing that sub-sample instead of having to harvest the entire plot. So that was study one. Now study two, I wanted to look at doing just a non-destructive aerial and ground method, where we wouldn't have to go in and clip the entire plot nor take a subsample. So the first part would be the ground method. And that would be, again, doing the visual rating and then doing the plant height, same as in study one. But this time I would use a handheld NDVI meter. Now I'll kind of talk about that a little bit. So it's basically just a sensor that looks at the red and infrared light. So you'll go through a plot. Once you'll use this device, you'll hit the trigger, you'll kind of scan the plot, and you'll let go, and it'll give you a reading. And we'll kind of talk about that a little bit. There's a picture of the actual, NDVI meter. It's very inexpensive. It's about a $500 meter. So you're not investing a whole lot into equipment and things like that with this. And this figure to the, I guess would be your right, kind of sums up how this meter works. So if you look at, you have reflectance, and up there at the top, you'll see the visual spectrum. So that's what we can actually see, red, green, and blue. So that'd be the RGB right there. Just outside that visual spectrum, you have NIR, which is near infrared. So we cannot see that with our eyes, right? Now, if you look at the vegetation curve, it'd be the green line there. You notice you have a dip right there on 3, which is the red, and you have high absorption there. And then it spikes up to the NIR band, which we cannot see, but there's high reflectance there. So the NDVI takes advantage of that difference. If you look at the formula here, it'll be NIR minus red divided by NIR plus red. And that will give you your NDVI reading. Now the figure below kind of shows you what you could expect. So if you have a low NDVI reading, it shows kind of unhealthy plants, things like that. And a higher NDVI reading, you're going to look at more healthy plants. Now, study 2, the second part of it would be doing an aerial, aerial estimation. So, and again, it would be the non-destructive method. We're looking at plant height again. This time you could either do plant height physically or you could use the UAV to obtain plant height. And the second part would be doing a visual spectrum RGB indice. So for this part, I use 6 different indices, and we'll kind of get into what that means. So if you look at the figure in the middle, it's about the same as the other one, but here you see we still have the vegetation curve, and it peaks up there in the band 4, which is the NIR band. And you still have that dip in the red band. But this time with the RGB sensor, since we don't have that ability to use that NIR, we just have to rely on the little peak there at the green and the dip there at the red. So a lot of people say it's not as good, but I kind of challenge that a little bit. We still have some good differences. So our rotary UAV, again, is equipped with just an RGB camera. So the data was collected with this Phantom 4 multi-rotor drone, and it's just a regular 12 megapixel camera. And we took about 1,200 pictures in the flight pattern, and it was about an 80% coverage. So once you have those 1,200 pictures, I used a It's actually a free software to process those images and stitch them together. And it's called Microsoft Image Composite Editor. And then this is the resulting image of all of our pictures we took. So it just gives you one nice image there. Now, once you get your image, you need to do something with it. So I loaded the image that we got into our Envy software, and I drew polygons, these little rectangles over each individual plot. So once you have your polygons drawn, you can you basically can just click on. Uh-oh. There we go. Okay. Maybe I touched something. Basically, you can just click on a plot, and it'll give you these statistics for that one plot. So over here, this is plot 101, and you see I have 3 bands, the R, G, and B. So I only have the 3 again. And you want to look at the plot mean. So the mean runs from 0 to 255, and that's the reflectance number. So once you have all those, you could decide which indice you would want to use. There's 1,000 indices out there. I selected, 6 of them or so to kind of use. And what you do is you just basically, you see the abbreviation there, maybe the red-green vegetation indice. You just take the red number, which is band 1, divided by the green number, and that will give you an indice. So. Okay. Oh, and here's my summary. This is not all of my data or all of my results. There's a lot of results because I did this on pretty much everything across the whole study. But I wanted to talk a little bit about it so you can see kind of the possibilities of it. So for the traditional method, the forage estimation, that's just, again, looking at the visual rating, the plant height, and the subsample. So the species, I selected which species kind of benefited best from this method of estimation. And then also, again, I looked at the evaluation time, because again, we're doing three to 4 clippings a year. We had the fall, midwinter, early spring. So for the visual rating, it was winter barley had the highest correlation, and it was during the early spring evaluation. We had an R of 0.92, pretty respectable. Now, when we combined all of the species for the fall clipping, we had the highest R at 0.84. And then you can see plant height, it was triticale. Now, again, was in the fall, and that was a 0.95. And when we combined the species for plant height, it was a 0.81. For subsample, winter barley in the midwinter, again, a 0.91. And subsample across all species in the fall was the best time to do that evaluation at a 0.8. Now, I wasn't happy with just using one of these methods, so I wanted to see if I could utilize, multiple methods, see if I could get 1, 2, or 3 of these variables to, kind of make sense of our forage. So I did a stepwise backward regression model, and I utilized the visual rating, the plant height, and the subsample, and with a combined species across all the clip times, we had an R square of 0.78, which is pretty respectable for having that much variation in the field. You've got all these different species. Now, during the non-destructive part, the ground method, again, the visual rating, this is on a separate data set. For winter barley, it was an early spring and a 0.87. Plant height, again, triticale in the fall. So triticale really matched up well to getting the plant height, and it gave a good estimation of forage for triticale. And NDVI best lined up with ryegrass, which I found was interesting because ryegrass, if you look at it, is really dark green. It really stands out at you as opposed to these other species. So that reflectance NDVI gave a good estimation of ryegrass in the fall at a 0.98. Now again, I wanted to try the see if I can create a model that would give us, good combinations there. So for visual rating, plant height, NDVI, for combined species in the fall only, we had a 0.87. However, when we used that same model and added all the clippings, that dropped down to a 0.58. So that kind of tells me the fall is the best time to conduct those flights and do those handheld measurements, maybe about a month or two after planting. Now, the second part of that study is the arrow method. Now, again, we did the plant height, and you see triticale in the fall. Now, this one, the R by G vegetation index, did best for ryegrass. Again, in the fall, we had a 0.89. And then again, we did the model, and instead of using R by G, it used GR, little g, little r, and plant height. And we had a combined species in the fall of R square of 0.89. But then again, whenever we combined across, all clippings, that dropped way down to 0.36. So that's just kind of a brief overview of my last few years of work. Now I want to talk about my vision for the farm. There's a lot of different systems, that kind of rely on this farm, and how better can we serve all of these systems? And I think if we look at the mission, the land grant mission of teaching, research, and service to extension, always keeping the mission in mind would do us a lot of service here. So, beautiful farm, beautiful campus. I just took the tour. A lot of potential out there. How can we best utilize this area? And I think by looking at the three mission things of teaching, research, and extension, we can answer a lot of those questions. So one of the things I think, maybe working with educators to utilize the farm as kind of a hands-on lab. There's a lot of good classes here that I've seen in all of animal and food sciences, plant and soil sciences, agribusiness. A lot of things you can learn in a book, but I think getting out there and putting your hands on things like that, crops and animals, and seeing it firsthand, I think that goes a long way. So maybe increasing some of the hands-on opportunities for learning. In addition, I know we're working on getting more undergraduate and graduate students involved in things and research projects, and supporting those projects, is very important. So there's a lot of potential there for that. And there's like on campus, we have the Howdy Farm. I know the University of Georgia has the UGuard, and LSU has the Hill Farm community. And that's just a way that kind of students could get more hands-on experience growing their own crops, things like that, having farmers markets, or even donating to food banks and things. I think it's a great opportunity to get more involvement with the students. Now, as far as research goes, I think working with the current scientists, there seems to be a lot of research going on now that we can kind of help support, and even explore new research opportunities. I'd like to encourage scientists to have continuous research trials, keeping an active farming approach in plant, animal, and horticultural food systems. Another thing I'm really big on is conducting forest trials, so support large and small ruminants research. These trials could be geared toward nutrition, alternative crops, grazing preferences, increased biomass. This could kind of unite plant and animal system science. Now, to add to that note, I found a few examples here, but just exploring ways to kind of integrate between research disciplines like plant and animal science. So Here's one I found. It's a research journal on nutrient value of sweet potato, and forage is goat feed. Another one here is forage intake and efficiency of feed utilization in dairy cattle. So there's a lot of things you can kind of tie together between these disciplines. Also collaborate with other scientists from other institutions on grant proposals, joint research projects. I think that's important to have, not only does it, get you better, I guess, ideas, sharing of new ideas, it also increases publications and research dollars. So there's never been anything bad that comes out of collaboration that I know of. I'm sure there is something, but usually very positive. So as far as extension and services, I know you guys are doing this a little bit, serve as a community education center, crop and livestock producers, both large and small, operations. Extension and research projects that are kind of designed to support small scale, crop and livestock producers. How can we optimize their production no matter the size of their land? I think there are some crop testing opportunities, demo plots for small grains, forages, corn, sorghum. They could be associated with like field days and things like that. Work with county agents, pesticide safety education programs, maybe offer CEUs to kind of draw more people in, and definitely feed them. That's nothing turns out a producer like feeding them and giving them CEUs. Another one, I think forage is important. Like I said, it kind of bridges that gap between animal science and plant science. Maybe look at a cool season annual forage rotation study. This could benefit both research and extension. It could serve as a demonstration on how to properly implement a rotational grazing system. Maybe look at conducting long-term perennial grass grazing demonstrations. You can add treatments to this. Different goals. I think root carbon sequestration. Extension could use it as a producer demonstration, things like that. Also, I think one thing I've always wanted to try to do was maybe a year-round forage study, where you evaluate the sustainability of rotating, summer annual Sudan grass, millets, things like that, and winter annual forages like small grains, winter peas, ryegrass, things like that. I think that would be an interesting thing to look at. And maybe even conducting forage trials. I think a lot of universities put them on. They all come up with annual publications, mostly in cattle, but I think having something to do with, cattle and goat forage, get that information out to the public, through publications and things like that. I think that would be, something very useful. And finally, I want to talk a little bit about utilization of land. So I think land that's not being utilized for research, extension, or teaching could be put into production to help with funding. I think that's an important thing to always have a proactive and active approach to the farm. You always want to see something going on. I mean, it keeps everything kind of exciting. Depending on the equipment, which I've seen, we have the proper equipment here. It's you're looking at wheat, corn, sorghum, could all be put into production. In addition to funding, you could use these as demonstration fields or student labs, extension field days, things like that. And also hay and forest fields could be utilized by animal science and livestock, which they seem to be currently doing. So, and that's all I have. That's my son watering the garden. I don't think any water hit the plant at all. Water use efficiency, that's what I thought about. It's the scientist part coming out. So, thank you. Any questions? Thank you. Oh, oh, yeah.
Okay. Thank you, Mr. Semino, for those are some good remarks and some great ideas. Do we have questions from the audience at this point? Anybody? Just hot question, Gary.
What are your thoughts on using like high tannin plants to control parasites in small ruminants?
I'm not as familiar with that topic, but I'm definitely open to any suggestions you have in research. And I think that's the main thing is just being open to new ideas and willing to do, research on those topics. So I'm sorry, I'm not as familiar with that as I hope to be. Yeah, I can hear you.
One of the challenges is that they don't eat
Right.
very distinct, different. Matter of fact, one of the unique features not from say food. So how would you look at that?
Right. I mean, just off the top of my head, when we were driving through the farm, I noticed several 1 acre sections that were sectioned off. I don't. I think keeping the forage separate. That was not. During the publication part was not my intention to combine them for cattle and goats, but having maybe a separate section. Because yeah, you're right. I mean, I did a little bit of looking on goat, and they, alfalfa. They have just a whole different array of things that cattle producers would look at. So yeah. Hmm. Yeah. Right. Hmm. But I think that's a good point, and that's something I think these publications could help resolve because I think a lot of producers and small scale people want to get into this, goat research. They don't know these things. So if you have a publication on your website that says goat forages, that would go a long way, and then you have cattle forages on this side. So I think that would go a long way, and I don't really see that anyway. So that would definitely be a novel thing for this university to undertake. And it's not hard to do. I just showed ways to do some of the different ways to do things. I mean, you don't always have to rely on a $200,000 forage harvester to get forage work done. You could do it a little bit inexpensive if you would like.
So, based upon your experience with wheat varieties,
Uh-huh.
one of the issues that we've dealt with down on this part of the coast is rust issues.
Yes.
Are there some rust-free wheat
We're
that
working
can
on
grow
it.
down this way? So we actually grew some cover crops last year as part of one of our
Mhm.
crop production classes, and we actually got it to go to head this year, this spring, and I've never seen that happen before without rust overtaking.
Correct. I mean, a lot of it. So here's the problem with wheat in this area, and it's not a problem. I think it's an advantage. Is you're right in that zone to where, winter wheat, if you're having a warm winter, is not going to vernalize and produce a head, for collecting. But spring wheat, it doesn't require any vernalization. So, however, spring wheat can freeze out if you plant it too early. So it's wheat's complicated. But yes, to answer your question about the disease, yes, there are disease-resistant varieties out there. A lot of them, you just have to do some research on them because a lot of the co-ops and things like that, they don't want to really sell certified seed, and that's usually the best quality seeds. You'll have more disease resistant things like that because they have to pay royalties on certified seeds. So they'll do like they'll just call it generic wheat, or I see this one a lot is oat, because I've worked with oats for 10 or 15 years, and it's hard to release an oat variety because all these co-ops and things like that, all they want to do is that they want to sell the cheapest one without having to pay any kind of royalty. We're changing them. We're changing their minds slowly but surely. Very good question on the wheat.
So there is another question here coming from online viewers. He's asking, he's a scientist, Ram Ray. He's asking, we are having serious issues on getting rid of weeds.
On weeds?
Yeah, weeds.
Okay.
Do you have any idea on this?
Yeah, I mean, it just depends on the, whatever crop you're growing. There's so many herbicides out there that are just tailored for, say for cotton, or for sorghum, or for corn, wheat. Like I can't, a lot of the cotton varieties and corn and sorghum varieties are Roundup ready. So you can go right over them and spray Roundup, and it's not going to touch the corn. But if I did that in my wheat field, I would kill everything because wheat is not Roundup ready. So I use other chemicals like 2,4-D and things like that to control weeds and wheat. So it's all crop specific.
The other question is that we have a lot of pasture land here that needed to be converted to cropland to do more research in the crop area.
Correct.
So what is your vision on this? How, because majority of our farm right now is the pasture land.
Right.
And crop research are going to be future.
Yes.
They're seeing, so how you do that?
Well, I think, to transition a field from pasture land to cropland, I mean, it takes a couple years to mellow the ground back out, and usually you'd have to go in and you'd run a ripper across it, they call it, and then you continuously have to work the land, right? But it can happen. I mean, it's it's going to take a lot of herbicide, a lot of weed control, because a lot of those pastures have gone to weeds, and then that seed is still in the ground, and it'll come back every year. So you want to plant a crop that you can easily control the weed. Like I said, if you get something where you can just hit it with Roundup and knock the weeds back and let your corn go through. I do crop consulting on the side, and I had a farmer who he grew rice in his field for many, many years. And just the following year, he said, I'm going to go ahead and put cotton there. So he rode it up. He planted cotton. I mean, it was rough. We had a lot of clods in the soil. We had a lot of unique weeds that were coming up through the rice. But I mean, we made it work. So you could do it. It just it's better to give it a few years to kind of, mellow that soil and get it used to row cropping.
What type of return you see on a per acre basis from some of the fall forage crops that you focused on earlier, and maybe what kind of return you'd see a limited resource farmer get? Could we justify this for limited resource farmer?
Right. Yeah, I mean, I'd have to kind of do more research on the forage selling, because I know you could do a lot of silage. You could work with companies that come in and they'll chop say if you're growing sorghum silage, it gets 10 feet tall. They'll come in and they'll chop that for you and pull it out of here. I'm not sure on the prices on that, but let's say for corn, you can expect, I figure on, dry land corn, you'll get about 100 bushel yield. And with that, I mean, that corn, I think it was at 350 a bushel. So you're making about 350 an acre. But then you might have another, I know you got $100 in seed costs per acre. And then you got some, you want to put a lot of nitrogen out. So you're looking at about $150 an acre for corn. That's at a low. That's only if you're putting out 100 bushel. Sorghum's about the same. Wheat, hopefully you can expect a little bit more, about 200 or something, $200 an acre.
Uh, I know you had on one of your slides, but I was sort of distracted and I missed it. But I wanted to, if you could elaborate for me a little more on integrating student projects and student-led projects such as the student-led garden.
Right.
And how do you weave that into the activities that you do on the farm?
Well, I mean, there's plenty of land here to section off a spot for that. We would have to prepare the land. You know, I guess it works best if you have like an agronomy society club or things like that, where you can directly get feedback from the students on what do you guys want to do, what kind of crops you want to grow. You know, I mean, we could do, you know, some a little bit of row crop, things like that. But I think getting direct feedback from the students, figuring out what they want to do, and then just making it happen. Because we have the equipment, we have the space, we have all the resources they need. So I believe in just being very open-minded about things. I mean, approach me with an idea, and I'm going to work with you on how to, you know, overcome all the problems and obstacles. Because every idea has obstacles. So.
Thanks, Brian. Excuse me, good presentation. So, question about what is your leadership style like?
My leadership style, I've never liked to be micromanaged. I believe if you train a person correctly and you give them tasks you know that they can accomplish, I think it builds that person up and it motivates them to do better. You know, so if I give someone a job to do and I say, okay, here you go, here's what I want you to do and how I want you to do it, and I leave them alone and they come back and they do a good job. I mean, it's like they feel like they did that on their own. They didn't need anyone supervised. And then you build from that. You give them a little bit more complicated tasks and things like that. So, you know, I'm not a micromanager. I like to assign and oversee, I guess would be my style. So I've had people who like to be in the mix of every little thing. And that doesn't say like if someone needs help with anything, I'm not there or available. You know, I definitely guide that person step by step. Yes, sir.
Coming from a farm, me being raised on a farm,
Oh.
and I know for this to be a teaching university,
Mm-hmm.
I know there is a lot of entities that have not been incorporated here. So for beef cattle, if you want to do research on beef cattle,
Mm-hmm.
how would you incorporate that? And also equine. I know that they got rid of the equines that was here.
Mm-hmm.
How would you expose your students, the students here, to all these entities? You have equine, beef
Right.
cattle. How would you incorporate swine, bringing the swine center back online? How would you do the poultry, bringing poultry back online?
Mm-hmm.
All of that is not operation, and that is part of our research, and that's part of exposing the students to everything, being well rounded, not just only for you see cows out there now, you see the beef out there, but you're not doing no research with it.
Right. Right.
You have goats. That's the only thing that you're being exposed to, but everything else you're not having any research with. So how would you incorporate all of that, being exposed to everything?
Right. Well, I mean, I think as the university grows and as researchers into different disciplines, such as animal science and things like that, you would hope you could work with those researchers and get some of those animals out there that you can. So it'd have to start increasing with the scientists who are actually working with them. And if not, you'd have to really, I mean, it's, like I said, I'm a hands-on guy. I like to get out there and look at things and get out there with my hands and you'd have to, you know, rely on online resources and things like that, which, you know, it does happen. So, but I would hope, you know, increasing the scientists here in different disciplines, equine, swine, things like that, and then bring their research projects here and support their research projects. So let's get some, hogs out here and things like that.
Okay, there is another question from the remote audience. She's asking, what type of environment do you prefer to work in? How would you handle a difficult employee?
Yeah, I mean, as far as the type of environment I like working in, I hate to ask if you can elaborate on that. I enjoy working outdoors. I enjoy working inside. I don't mind. I don't mind either situation. I like working as a group. I like coming up with new ideas with other people. Um, but I don't mind working on my own. I've had to do it, many times. And as far as dealing with difficult employees, I think we've all had to do it. I think anyone can be trained on things and retrained and work with that person, you know, as much as you can.
The other question is from one of the scientists here, Dr. Kebram. Experience with farm, do you have experience with farm machinery? Are you certified pesticide applicator?
I am. I have a non-commercial pesticide application license, and that's required for my work. That type of license. And I'm not, I'm ready to get on a tractor today. So I'm not, I actually enjoy that type of work. Oh, online.
Yeah, there are actually 50 people watching you online.
Oh, well, I'm glad you told me that after.
So the other question is, what special resolution can you get for forage data or crop yield or NDVI using drone?
What you talking about? Can you repeat the question?
Basically, it is asking that what resolution you can get using your technique or drone, using NDVI, or for your forage or crop yield.
So
the resolution.
So there's one about the resolution. Well, the way this particular, you can see it's kind of, cut that light. You can see the detailed imaging. This is just a cheap RGB camera, right? But what we're also trying to do, not only with forage, we're looking at detecting rust on wheat plants. So this is not the highest quality or highest resolution that we can get. We're trying to work on to where, because we'll also, instead of planting plots, we'll plant what we call hedgerows. We'll take the head of one wheat plant and plant that in one row, and it's usually a 2 foot by 6 inch. So we're trying to get the technology from UAVs to be able to detect rust on those very small rows. So you can get very detailed and get some good resolution. But I didn't need it for this project. It was just looking at reflections.
Okay, so there is no counter question on that, so it should be all right. See, there is a question from Extension. Mm-hmm. How do you plan to work with cooperative extension program? Will you allow plots for CEP?
Yeah, like I
CEP
said,
means cooperative extension.
Okay.
CEP means cooperative extension program.
Oh, absolutely. Currently in my role, I work as the research associate, but I work almost side by side with our extension wheat specialists. That's just the way we put plots in the same field. We go to the same fields together. I take part in their field days. That's the only way to do it. It made my life so much easier is working with extension, to be honest. Yeah, it's definitely. I don't see how I could do it without working with extension, to be honest. So definitely facilitate any needs that they have. And like I said, I'd like to see more crop testing here done. Like our extension service does wheat plots. So we have fields down in Wharton where we'll plant our variety trial of spring wheat and we have a variety trial of winter wheat in the same field. And, you know, I'll go down there and I'll take notes on it. And it's really just an extension part, but because they're doing that for their publications. But to me, I think that would serve this area great. You know, if we can have those plots out here and see how the winter wheat and the spring wheat compete and things like that. Oh, I think I'm restarting.
Okay, before we go, it's almost noon. I want to pose this question for you, or maybe a comment and then a question. What is your future vision? Now, I've been around long enough to remember when we were talking about Y2K, then we were talking about 2020, and we're already into 2020. And now we're talking about 2050. In the midst of challenges that we're having now, for example, we in COVID-19 and all those things, and the strain that it's putting on not only our health sector, but our food supply chain system. We look at where Prairie View's farm is. We're on the urban fringes of one of the fastest growing cities in the country, and Houston is growing this way every day. As a farm director, if the Board of Regents or the Chancellor come and say, we can no longer afford to allow you to grow wheat and sorghum and soybeans on that 800 acres because it become too expensive. What is your argument or counter argument going to be of why we should continue to hang on to an almost 800 acre farm when there are other competing needs and issues? It's going to put pressure on you to give it up for other competing uses.
Well, I think you said it yourself. We're looking at, you know, 2050 food shortages and things like that. And, you know, working with wheat for so long, we've always tried to increase yield. As, you know, the population grows, you want to get more out of that piece of land, right? A lot of things that I think one thing would be looking at, like I was mentioning, the spring wheat and winter wheat uses. Usually spring wheat is a northern thing. It's grown up there in Montana and all these things. But South Texas is a unique environment. So I think increasing crop, the ability to grow crops in different areas. You know, I would kind of convey to them the importance of trying to increase yields and things like that, but also increase land that we can utilize for these things and forages and things of that nature.
Thank you. This is going to conclude our presentation for today. We thank you all for your attendance today. Those of you online, thank you for tuning in, and thank you for the question that you submitted. I believe this has